Hi everyone. So today we're going to work on the lesson titled Real Number System. It should be lesson 1 in the Unit 10 packet. Hopefully yesterday you watched the video and you answered the questions that were on the pages previous, and now we're going to go over some more stuff that has to do with the real number system. So also from yesterday, there were a few different groups of numbers that you learned. So what you want to do is try and think of those, write it down, and then you can watch the video to see if you're correct. So those types of numbers are natural numbers, whole numbers, integers, and rational. Now you also heard probably irrational numbers and real numbers, but we'll get into irrational numbers actually more today. So the one thing is that all of these numbers are real numbers. That's what it's called, the real number system. Okay. Number 2, write the numbers below as a decimal, do not round. So you do need your calculator for this. You can use the calculator that is on the computer on Haiku, or if you have a different calculator, you're welcome to use that too. So again, pause the video, write down the decimal value of all of the numbers shown A through E, and do not round. Okay, the answers are up. Please take a look at those. You should have the same decimals that I have. Number 3 asks, which of the questions above have decimals that repeat? So a decimal that repeats means that there's some form of pattern in the decimal. So we can look at each of them separately. The first one, we see that the 6 repeats. So we definitely know that A is one of the decimals that repeats. B does not have a decimal that repeats. C, yes, we see the 8 twice, but there's no pattern. It's not 4, 8, 4, 8. So actually that does not repeat. D does not repeat, and E does not repeat. So just A. Okay, next question. Which of the following above has decimals that end, meaning like it stops, it just doesn't keep going. There's no dot, dot, dot at the end. So that would be B stops and D stops. So B and D. Which of the questions above have decimals that don't repeat and they keep going? So no repeat and they go on forever. That would be C, because they don't repeat but they keep going, and E. Okay. So it says now we look at numbers written in decimal form to determine if they are rational or irrational. The definition of these categories of numbers are listed below. So this is like the formal definition of rational and irrational numbers. As long as you know what you understand the definition, then you can kind of say it in any words that you understand. So a rational number is any number that can be written as a ratio of 2 integers. So the rational numbers are, these are your rational numbers. You have B is rational, A is rational, and D is rational. But your irrational numbers are any numbers that cannot be written as a ratio of 2 integers. That's like pi, like square roots of numbers, like 10, where it doesn't come out to a nice whole number. So if you take a look up here, your rational numbers are numbers that do not repeat and they go on forever. So those numbers are C and E because they don't repeat and they go on forever. So it says, what does non-terminate, non-repeat mean in your own words? Well, that's however you think. Something along the lines of it doesn't end and it doesn't follow a pattern. The next part says, can a number be both rational and irrational? If yes, can you come up with a number to support your argument? The answer is no, a number can't be both rational and irrational. It has to be one or the other. Okay, take a moment, pause the video, and you can go through these ones. I'll go through the first one with you. A is the square root of 10, so you should be putting the square root of 10 in your calculator. And write down the decimal again, don't round, but you can put the 3 dots at the end if it keeps going. Okay, so you have to ask yourself 2 questions. Does it end? Does it repeat? If you say no to both of those questions, it is an irrational number. So this decimal does not end. This decimal does not repeat, which means it is irrational. And my explanation is going to be the decimal doesn't end or repeat. I'll do one more. Why don't you go ahead and put the square root of 4 over 5 in your calculator? Okay, so now you can ask yourself, does it end or does it repeat, or neither? This decimal does end because we answered yes to that question. It is a rational number, so we can write that the decimal ends, or the decimal terminates. Okay, pause the video, try the next few. Okay, go ahead and look at the answers. Only the first one was irrational. The rest of them were all rational because they either have decimals that repeat or they're decimal stops. Number 8 is a circle of the irrational numbers in the list. What you're going to have to do is turn them all to look like a decimal and then circle the ones that are irrational. So again, go ahead and do that, and then I'll show you the answers. Okay, so you should have the square root of 3, the square root of 2, the square root of 8 over 2, pi, and 2 pi, all as your irrational numbers. You turn them to look like a decimal, and you looked for the ones that did not repeat and did not end. Okay, now we're going to put not only what we learned yesterday about natural, whole integers, rational, irrational, and real numbers, we're going to try and put them into categories. So you may want to also be looking at a reference sheet in order to do that. So the first thing is all numbers are real numbers. So we know that all of these are actually going to be real numbers because that is just the category of all numbers. Then, if you want, we can work backwards. Which numbers are irrational? Well, only 5 pi is irrational because the other ones are not decimals that repeat and we know pi is an irrational number. Which numbers are rational? Well, if the number is not irrational, that means it has to be rational. Integers are your positive and negative whole numbers. So 0 is an integer, 2 is an integer, and negative 2. 2.2 is not an integer because it's not like 1, 2, 3 or negative 1, 2, 3 or any of those. Decimals and fractions are only rational numbers. Whole numbers are just positive counting numbers. So 0 and 2. And then natural numbers start with number 1, so 0 is not included. And you could also have used this like graphic right below it to help you answer the questions above. Which of the following numbers are rational? You have to put it in your calculator, turn them all to decimal, and figure out which ones have decimals that do repeat or that they do end. So that's going to be this one. That's going to come out to 14. This one. And this one, because it's just 2.5 repeating, so it is a repeating decimal. So you can write as your explanation, the decimals repeat or end. And then which of the following are irrational? Well, those are all of the other ones. Oh wait, did I miss one? No. Okay, so they are irrational. That's going to be this one once you turn it into a decimal. And this one. All of the other ones have decimals that repeat or end, so the decimal does not repeat or end. Okay, now you can do number 12. Come up with 4 of each set. And that is it. If you have any questions, please email me, and have a great day.